Hey folks, so this is a second video in section 1.7. I'm going to make a couple of videos here, but just a couple of concepts here. If we'll go down, I know some of you wanted to know what we did on the rest of these in this table here, and so I went ahead and filled out the rest of it so that you can see. If you were in class, we did just a few. Even in prior videos, I did just a few, but if you wanted to see the rest of them, here they are. So you can pause this video and take a look at that. But what I really want to talk about right now is the quadratic inequalities. And a quadratic inequality is going to be in this format of, let me get my laser here, in this particular format where I have the squared in here. And in order to solve an inequality, just a couple of concepts. First of all, rewrite the equation or the inequality so that 0 is on one side. I'm actually going to show you two different methods on this, especially when I get down to the rational functions. But just be aware that you could have 0 on one side or you could have a number on the other side. But for now, we'll say 0 on one side. For step 2, set the expression of the equation or the inequality equal to f of x and graph. So this is the big deal here, just graph. And basically, if we're looking at this example, you would graph what's on the other side of that 0, graph the function. And then we're going to use the graph to determine our solutions. So if our graph, here's f of x, our graph. If our graph is equal to 0, then these are going to be all of the values that are x-intercepts or are zeros of our function. And so this is what is on the x-axis. So I just like to go ahead and say these are the on the x-axis. And then if my graph is less than 0, this is wherever our graph is going to be below the x-axis. So this is below the x-axis, and then when our graph is greater than 0, this is where the graph is going to be above the x-axis. So let's just go ahead and pick this apart and see exactly what this means. Now, sometimes it's going to be easy enough to, sorry, I accidentally unhid those. Sometimes it's going to be easy enough to graph without the aid of a calculator. So on a few of these, I will graph without a calculator. On this very first one, notice that what I did was I went ahead and I set it equal to 0 to begin with, to just treat it like an equation first. If I were solving this equation, then what I would do is I would factor it, and then I would set up my mini equations and I would solve. So I would have x equals -3 and x equals 5. Now, graphically, what that means is that x equals -3 and x equals 5, these are x-intercepts. So let me go ahead and unhide the graph. You'll notice you can do this on the calculator or you can do this by hand. We're going to be learning more and more about graphing, so if you need to depend on the calculator, that's totally fine. But notice that I have an x-intercept at x equals -3 and another one at x equals 5. And my parabola is pointing in the upward direction. Just for free here, notice that my y-intercept is going to be my c value. So since my c value is -15, then y equals -15 is my y-intercept. So that's kind of for free there. But we'll use that a lot in the days and weeks to come. Now, what we're being asked for is, where is our graph less than or equal to 0? So I want you to start thinking about this concept above and on and below. And so when I look at the x-axis, anything that is on the x-axis is, well, on the x-axis. And then we have everything here that you're seeing is above the x-axis. So this is going to be where my graph is greater than 0. And then down below, this is where my graph is less than 0. What we're being asked for is everything that is below or on. So I want anything that is either on my x-axis or below my x-axis. So all of this in here is what I want. Well, our graph then, and for the record, we're always going to use x values to state this. So that means that from the x value of -3 all the way to the x value of 5, all of my graph is going to be below or on the x-axis. So from -3 all the way to 5, and then since we wanted the on values, we are including the -3 and we are including the 5. Okay, now let's go to another one. All right, so once again here, we've got this particular quadratic. I pretended like it was an equal to. I did not write that, but mentally I pretended that it was an equal to. And you can see here the equal to that I have. I went ahead and factored it, and then I solved so that I got my x-intercepts here of x equals -1/3 or x equals 4. So I went to either my calculator, or if you know how to graph, like I said, we will be learning that more and more in the days to come. So don't worry, you can use your calculator here. Notice that my x-intercepts are x equals -1/3 and x equals 4. Up here, we are being asked for everything above the x-axis. And if I unhide the tape here, you can see that I only want what is above the x-axis. This time I don't want what is on the x-axis. All right, so I only want what's above. Notice that what is above is in 2 pieces. So our answer will also have 2 pieces. These are the 2 pieces where our graph is above the x-axis. Now remember, we're only going to be using x values for this. Okay, so when we think of x values, and let me see if I can get myself a vertical line here that will be of assistance to us. All right, so I've got this vertical line. Let me see if I can grab it, if it'll let me. And what I want to do is just kind of show you all these x values that allow me to be able... Sorry, struggling here. There we go. All right, so even though you can't see my graph way over here, I still know that this graph is going to go way, way, way up. And so where this x value is, like maybe this is at, let's see, this is -1. So here's x equals -2. Even at x equals -2, my graph is above my x-axis. And at x equals 4, it's above the x-axis. And at x equals 6, and at x equals -8, -6 that is, and -8, and -10, and infinity. All of these values back here are going to have my graph above the x-axis. So we would say then that we're starting at -infinity, and we're going to go all the way to that x value of x equals -1/3. So from -infinity all the way to -1/3. Now remember, we did not want the ons, so that's why I've used a round parentheses here. Then the next time that we are above the x-axis is not until we reach the x equals 4. And anything after x equals 4 is going to be above the x-axis. So that will be from 4 all the way to infinity. And again, that x equals 4, we don't want what's on x equals 4. We're not including x equals 4. It's only going to be after that. All right. Now let's take a look at finding the height of a projectile. This is where we're going to stray just a tad from what we did previously. So let's read first what we've got. It says that a projectile is launched from the ground. It's got an initial velocity of 144 feet per second. The height is s. This is important to take note of. My height is s. And t is in seconds. So this is time. All right. So I can tell you then that height is the s value, and all my t's are going to be my time values measured in seconds. after launching is given by the following equation. So we were handed an equation. So what I did then is, let's go ahead. Let me take you to the calculator. And I'm going to try to do a split screen here. And in Y1, we're going to enter in this negative 16t squared plus 144t. Only we're not going to use t's, we're going to use x's. So we have, make sure that you use the negative that's below the 3. So negative 16. Instead of a t, use your x button. Your x button is right underneath the mode button. Negative 16 x squared. The squared button is catty corner or diagonal from the 7. So negative 16 x squared plus 144 x. And notice that we are being asked, before we leave this screen, we're being asked, when will the projectile be greater than 128 feet above ground level? So let's put in for the Y2, let's put in 128. So go down to Y2 and put in 128. Now we will have to adjust our window a bit. We understand that my projectile is going to at least 128 feet. So when I go to my window right now, I'm only graphing a Y maximum of 10 feet. And I need to go way far above that to be able to see 128 feet. So let's see here. For now, I'll leave my X-min and max alone. For an X-min, I'd take that back. Let's just take that down to -1 because we don't need negative time. For my Y maximum, let's go to 300. All right. And then you can go from there to graph. And what you see on the blue curve is the height of my projectile's path. And the red line is that 128 foot line. Now, I've gone ahead and I've graphed it here on my iPad, so because I can't use the laser over here on the calculator. So this is basically a replica of what we're looking at. And we want to know, when is the projectile going to be greater than 128 feet? So now we want to know anything that's going to be greater than 128 feet. So that is not what I wanted. Let me try that again. All right, so greater than 128 feet. There we go. And you can see, according to my little notations here, I'll uncover the tape, we want everything above that. We don't want what's on the 128 feet. We don't want what's below the 128 feet. We only want to know what's greater than the 128 feet. All right, so in order to do this, what we will need to do next is we'll need to find this spot right here and this spot right here, because everything here is, my projectile is greater than 128 feet. All right, so on the calculator, we're going to use the second trace function. So second trace, that's the same thing as calculate. We'll go in this menu to number 5. Now, for those of you using a handheld calculator, you need to be aware that what you see on my screen is going to be slightly different, and so I will walk you through what's different and what's the same. But we're still going to go to the intersect option for number 5. Now, here's where it's different. Yours is not asking you about left bound. You see at the top of my screen, it says left bound with a question mark. Yours actually says first curve. As long as one of those two, Y1 and Y2, is your first one, then you can go ahead and push enter. I need to get to the left side of my intersection there. And for the record, let me come over here to the iPad. Your cursor needs to be close to this intersection. I'm sorry, I circled the wrong one. It's close to this intersection. So get your cursor close to this one. Once you get close to that one, then you can push enter for your first curve. I'm going to push enter that this is my left bound. Yours is not asking you for right bound. Yours is asking you for second curve. I'm going to go to the right. You don't need to move at all as long as you are close to that intersection. But I needed to move. Yours is going to ask you if you want to guess. No, you do not want to guess. Now you will notice that this first time that it hits 128 is at the value, I'm going to draw it here on my graph, is at the value of x equals 1. Notice that at the bottom of your calculator screen, it'll say x equals 1, y equals 128. All right, so my projectile starts being above 128 right after 1 second. Okay, so then the next thing we want to do is go and find this intersection. All right, so what I'm going to do, let's go back to second trace. Number 5 again, only this time you need to get all the way over close to that other intersection. Get close to the other intersection. Now, remember, yours is saying first curve. Mine is not saying first curve. Mine says left bound. But even still, even if it says first curve, you need to get close to that other intersection. So I'm going to say enter now. This is my left bound, but you can just say enter at your first curve. You don't need to move. I need to move over to the right side. And then it'll ask you if you want to guess after it asks you about the second curve. And this time you'll notice that the second time that I have intersect that 128 feet is at an x value of 8 or 8 seconds. So let me unhide here this tape. You want to find when it's above 128 feet. And so what we notice is that starting at 1 second, it's really right after 1 second, and all the way right up to 8 seconds, my projectile is above that 128 degree line. Now, if it had said at or above 128 feet, then I would have used square brackets because at that point it would be on the 128-foot line, not just above. All right, this will be the end of this video.